All right, so Tristan drank a cup of tea and contained 40 milligrams of caffeine. The amount of caffeine in his body was measured repeatedly after drinking tea. And remember, it's a horizontal table. It doesn't matter. L1, L2, X, Y. That means that every single point is time and caffeine, right? In milligrams, of course. So determine the equation of this regression, exponential regression. I already went and entered everything into L1 and L2. And I already did the regression here. So you need, today, if you just have the equation, that's fine. And this is technically 4080, and it's 0.75 if you do 2 decimals. If you went more than 2, that's fine, as long as you round correctly. So if it's 3 decimals, I'd expect you to go 3 decimals would be 7.4747. If it's 4 decimals, it's 7474 because the 9 bumps that. So you know what I'm saying. And don't forget the exponent there. By what percent is the caffeine in his body decreasing? If you have it like I do, you would say 25% per hour. Okay. If you have it to 3 decimals, obviously this would be a little different, right? But it just matches. And if you're wondering what does the province do, the same thing. If you went 4 decimals, then we would just expect you to answer, right, to be 25 point something. Okay. Determine when half the caffeine remained in Tristan's body. They're asking for half-life, by the way. Okay, they're just not saying it that way. So I have to let y2 equal to half of what I started with. So 20, 40, okay. And then I'm going to go second, trace, 5, intersect. So first of all, I have to find this graph. If you're using plot 1, that's probably a good one. You can do zoom 9. There it is. And I will let y2 equal to 20.40 and see if it fits. It does. So I find the intersection. So it ends up being 2.38 hours. Oops. Okay. If you came up with that today, if you have the 2.38 hours, I'm fine with this particular. I don't give you a lot of room. And there's no way you could have guessed on this one. Are we good? No questions? Arian, you have a question? You're kind of itching.
Isn't that 2.45?
It depends. What did you use here?
Oh, I used the multiple decimals. I did 2 decimals.
So yours is not 2040? What is? Oh, sorry. What do you have here?
Oh, there I had which one is that?
Yeah. What do you have here in your equation?
I had 40.7986.
So you went half of that,
Yeah.
then you're fine. So that's probably, some of you may have put more than 2 decimals here, and then half of that will make this different, right? And that's fine. So it's the annoying part of this unit. But as long as you're consistent, we're good. Maybe some of you went, hey, at the beginning it's 40. How come it's, I know, it's trying to model it. It's trying to find the best way to connect the dots, basically, because they're not perfectly fitting the curve. So it's trying to make it happen. Okay. When will Tristan have less than 3 milligrams in his body? So caffeine, right? So we got to let y2 equal to 3. And go second, trace 5 on that one. And obviously your times are all going to be different. And so here's a window problem, right? You need to chase the curve. So I'm going to go, I don't know, 25. Let's see if that works. Yeah, it crosses. And that would be 8.96 for me. And obviously it's going to be different for, it should be the same in this case because you copy pasted this one into y1, right? Like if you do your regression and you paste the whole thing, because look at what I have, right? In my y1, because I pasted it, it has the whole thing in it. So it should, this should match. This one not, because you're going off of this, okay? The domain and range, so let this guide you. Okay, so some of you might need to make a little sketch and be like, I start there, I do this, okay? But it never ends. Like we're not told that it stops anywhere, okay? So for my domain, I go from time of 0 to infinity. Yes, you were told the whole time, don't do infinities, don't do infinities. But in this case, there is no indication that it stops unless it says, right, something different. Or did anybody try to find out? Because the thing is, it never touches it never gets to a 0 level of caffeine based on this diagram, right? You cannot find the x-intercept. So, which is a little bit of a misleading question because we all know that at some point you have no caffeine left. If you stop drinking coffee, at some point you will stop. Range. This is where the square bracket is going to get you in trouble. It's actually a round bracket, right? The lowest you ever get is almost 0, and you start at 40.80 or 40, right? 40.80. So your range is 0, but it's a round bracket. And this is 40.80 here, square bracket. So lowest, highest, okay? So you get 1 mark for each. Let's keep going. I already entered this, so we have bacteria, so number of observations and bacteria. So every single point is going to be observations and bacteria, right? So this is L1, L2. I bring that up. I'm going to do this a little differently here. I'm going to call exponential regression, but I entered this into L3 and L4. Okay? That way I can do this a little faster. So that's the equation that you should be getting. So stat, calc, exponential regression. You get y is equal to 4120.08, and this is 1.50 to the power of x. That is the equation that you're supposed to get there. 1 mark for that. Explain what each part of this equation above represents. Be very specific. Well, the 4120.08, okay, is the initial amount of bacteria, right? Times 0 it would be, but there's no observation, there's no time here, so we're just going to leave it like that. Okay, so you could say, right, that this number right here represents the initial amount of bacteria. 1.5, okay, indicates that there's a growth, right? There's growth at 50% per observation. If you have something like that, I would be fine. Okay. What does, and just to be specific, as we don't know, right, y is going to be what? Number of bacteria. X is going to be number of observations. Okay, so you're explaining every part, but you know what? Today, if you just give me these two, I'm fine. Those are the ones that the province will ask you quite often, actually. It's like, here's an equation. Explain what those numbers represent. Okay. If this growth rate continues, how many bacteria would you have after the 10th, on the 10th observation? Observation is my x value. So we go second trace value, right? X is equal to 10. Let's see if I can make this appear on my graph. I need to turn on plot 2 because I'm using L2, L3. L3, L4, I should say. Zoom 9. There it is. It's an increasing. I'm going to change my window a little bit. That's much better. So second trace 1, x is equal to 10. Tells me it's invalid. It's probably my window, right? My window is a problem. So I'm going to go to my window, change my x max to 15 or something like that. Let's see if it behaves now. It's way out, like it's way out there, but it allowed me to find it, so I'm just going to go with it. 237,559.65, so that's approximately 560 bacteria. Okay. That's what you're supposed to get there, so 1 mark for that. What's the doubling time of the bacteria? You let Y2 be 2 times 4120.08. That's essentially what I'm going to do. So Y2 is 8240.16. And then we go second, trace, intersect. And here we go. I need to fix my window for sure. Oh, this is actually a pretty, my Y max is 35,000, so I'm good. I can just graph this one. So I'm actually going to go 2 times 4120.08. You can actually do that. And there it is. Second trace 5. And the doubling time is x equal to 1.71. And what are the units in? Observation. I don't like the units, and I'm not going to lie to you, but I'm going to point something out in a bit why I chose this. But it's 1.71 observations, or between 1 or 2 observations if you must, because observations, you can't have a partial observation, right? Doesn't work. Maybe you peek with one eye, I don't know. But if you make an observation, that would be it. Okay. So a drug has been developed that affects the growth rate of this bacteria. When studying a second identical example with this drug, it was noticed that the bacteria only grew at 20% per hour. All of a sudden it's per hour? I didn't make this worksheet. Full disclosure, I make mistakes all the time. Anyways, we'll just go with it, right? We can flow with it. In this case, I will use the exact same value for the initial, but now I'm going to make this 1.20. That's the only thing I wanted you to change to understand, oh, if it's only a 20% growth, then this must be changed to 1.20. So 1 mark for that. So here's the total, okay? Let's go backwards so you know. 1 mark, right? So everything is worth 1. 1, 2, 3, 4, 5. But here's going to change. 6, 7, 8, 9, 10, 11. So because domain and range is separately, I'm going to make this 11 on the back side here. Okay, front, back side. What is the domain and range for exponential functions in general? No word problem. So you thinking on your study sheet, what do you call this here when it's exponential? Sounds like a swear word. Asymptote. You can use that, right? You're a pain in the asymptote. You can use that. So we know it goes like this, right? Either like this or like this. Those are the only 2 options for exponentials. I would have that on my study sheet, The domain would be all real numbers, or negative infinity, positive infinity, right? So it just goes side to side indefinitely. And so you got to make sure you go D and R so we know which one is which, right? For range, it's weird. It would be, if you want set notation, y is greater than 0. What's missing? You're so used to the equals, not for this one. It's just greater than 0. Or you go 0 from 0 all the way to positive infinity. That could also work. Okay, so we'll give you 1 mark for each. Whatever notation you prefer, you got that. Okay. What do we know about the x-intercept of an exponential function? There are none. Okay. Never crosses the x-axis or asymptote. Okay. What do we know about the y-intercept of exponential functions? It indicates the initial amount of bacteria, radiation, etc. Okay. What determines if the function is increasing or decreasing? The value of b. If b is greater than 1, it's increasing. If b is between 0 and 1, decreasing. So increasing, right? Go like this. Decreasing, go like this. Describe the end behavior of exponential functions. What causes this? It's always Q2 to Q1 or Q1 to Q2. It doesn't matter. What causes this? The horizontal asymptote. And by the way, the horizontal asymptote, what line goes right along the x-axis? What do we always graph when we're trying to find our x-intercept? Right? That is literally the equation of the horizontal asymptote. I've never seen them ask, but it's better safe than sorry. I'm going to give you half a mark. Well, no, I like 1 and 1 here. And then we're just going to keep it simple and just do 1 for the rest. So that's 1, 2, 3, 4, 5, 6 for this back side. And 11 for the front, right? 6 for the back, 11 for the front, 17 total. Make sure your name and last name is on there. And pass them forward, please. And then open your booklets. Can you just wait a little bit? I just want to explain the next part. And then you may go. Okay. Pass it forward. Grab your booklets. Go to 21. All right. Page 21. I'm going to say I'm going to say this. I think we need to move a little bit. You've been sitting a lot and listening to me. I'm going to make groups, and I want you to work on those 3 pages on whiteboards. I'll post the answer key. Actually, I won't post the answer key. I'm just going to have it right here, and one of you has to come over here and take the pictures and just report back to your group if you're doing all right. Okay? I don't want you to just think of it as time off. Think of it as what can I learn from my classmates, right? Because there'll be questions there that you might not know how to do. So when you go to that station, I want you to grab your calculator, right? Grab your booklet and be able to like participate because it's good practice. So this has to do with doubling time, half-life, things like that, because tomorrow we'll start with logarithmic functions, logs. We call them logs. So that's happening tomorrow.